Hello students, I am Dr. Deepshikha Acharya from Sagar Institute of Research and Technology Bhopal. In this video, I am going to explain about the de Broglie hypothesis. De Broglie hypothesis is one of the very important and earliest phenomena of the quantum mechanics. In other words, we can say it like wave-particle duality and or the dual nature of matter wave. बिफोर टू एक्सप्लेन डी ब्रोगली हाइपोथेसिस हमें समझने की ज़रूरत है कि ये डी ब्रोगली हाइपोथेसिस कहाँ से आया. इसको एक्सप्लेन करने से पहले मैंने आपको एक जो हमारा वीडियो था उसमें इसके पहले एक्सप्लेन किया हुआ है व्हाट इज़ द ब्लैक बॉडी रेडिएशन. ब्लैक बॉडी रेडिएशन इज़ वन ऑफ द अर्लीस्ट प्रॉब्लम्स ऑफ द क्वांटम मैकेनिक्स विच इज़ डील बाय द क्वांटम मैकेनिक्स एंड उसको सॉल्व करने के लिए प्लैंक ने वेव पार्टिकल ड्यूअलिटी का कॉन्सेप्ट फॉर द लाइफ डेवलप किया था. डी ब्रोगली ने उसी कॉन्सेप्ट को थोड़ा सा और इलेबोरेट किया एंड ही डिराइव द डी ब्रोगली हाइपोथेसिस. तो व्हाट इज डी ब्रोगली हाइपोथेसिस? Basically, de Broglie hypothesis says that every moving particle is associated with a wave and this wave is called a matter wave. When Planck says that light have dual nature and the energy of the light is confined inside a packet of energy, this packet of energy is called photon. So when light have a wave property and a particle property, similarly de Broglie think that if light have the dual nature, then why other particle does not have this kind of nature, because they are also a form of energy. And therefore de Broglie says that when particle is moving, a wave is generated or disturbance is created in the surrounding, and this wave is called matter wave, or in the name of the scientist de Broglie, it is also called de Broglie wave. The wavelength of this de Broglie wave is given by the formula lambda is equals to h by p, where p is the momentum. Therefore, we can write this equation as lambda is equals to h by p also. Now, how this formula is derived, we can explain. So, according to theory of relativity, total energy of any particle is given by E is equals to mc square. But according to Planck radiation law, which is developed for the black body radiation, E is equals to h nu, the energy of a photon. These are the two forms of energy. Therefore, we can compare these two equations, and mc square is equals to h nu. We can write like this. Now we convert nu is in the form of c by lambda, because we want to find the value of lambda finally. Now we move to the next slide. So, after this, we can write lambda is equals to h by mc, or lambda is equals to h by p. If we talk about the other material particle, mc is mass into velocity, so mv is also mass into velocity, where v is the velocity of the matter wave particle, or particle which is associated with the matter wave. This equation have the three form for the different situation. First form is the kinetic energy of the particle. If the particle is moving, then we know that energy of the particle, which is the kinetic energy, is equals to half mv square. We can convert this half mv square into momentum term. We can multiply and divide this equation with m, and now we can get m e is equals to p square by 2m. So we can write p is equals to under root 2m e. Substitute this value in the equation of lambda is equals to h by p. We get lambda is equals to h by 2me. So if we have the value of energy, then we can easily calculate lambda, because we know that h is the Planck constant, which have a constant value 6.627 into 10 to the power minus 34 joule second. M is the mass of the particle and E is the energy. This equation have the second form when the particle which is moving is of the gas particle. So for the kinetic energy of the gases, the energy equation is given by 3 by 2 kT. Substitute this value in the equation lambda is equals to h by p. We get the value of lambda is equals to h by under root 3m kT. And for the charged particle, the total energy of any charged particle is given by E is equals to small ev, where small e is the charge on the particle and v is the potential. So when we substitute this value into equation, then we get lambda is equals to h by under root 2 m ev. So these are the three conditions for the de Broglie hypothesis. I hope you all understand what is de Broglie hypothesis is now. Before to end this lecture, I want to tell you a very important thing, that every moving particle is associated with a wave. This is the statement of de Broglie hypothesis, but in the quantum mechanical laws are basically for the microscopic particle. Macroscopic particle does not identify or does not behave with these phenomena. So basically we are talking about the microscopic particle when we are dealing with the quantum mechanics like electron, proton, neutron, atom and molecules. So thank you student for viewing this lecture. Thank you so much.